Welcome to the second video, and today we will be talking about heat transfer, heat transfer in composite walls, when we have parallel arrangement, and also when we have a heating tape. Let's go into it. So when we have a slab, but we have a parallel arrangement. Now this is the problem. We have surface T1 at temperature T1, second surface at temperature T2. Then this top surface this will be K1 L1, this will be K2 L2, this will be K3 L3. The next surface will be T3 and finally T4, and this will be what? K4 L4. How do we draw the thermal resistance circuit? So we draw heat flux entering Q dot O, R1, T1, T2, then we draw R2, R3, T3, R4, and finally T4. Heat flux entering goes out. So what's interesting is the heat flux here, Q dot O, can go through this route and join here, or go through this route and join here. Simple parallel arrangement. Thus, Req is the series resistor R1 plus R2 plus R2 inverse plus R3 inverse plus R4. Total resistance. Total what? Equivalent resistance. How about the heat flux? Q dot O is equal to T1 minus T4, the entire heat temperature difference, the driver, divided by total equivalent resistance, Req. That's up to you to solve. Now let's go to interfacial heat generation. Interfacial heat generation, or in other words, when you have a heating tapes. Now what happens is you have first surface at T1, you have a heating tape. So it is the heating tape that gives heat flux Q dot H. Then you have here what? You have T2, and I call this TH. So the heat can go from here in Q dot 1 direction or the heat dot 2 direction. Let's draw the resistance circuit. T1, TH, TH, T1, TH, and then finally T2. What happens here? Q dot H heat flux comes here like that and goes in this and this direction. Obviously, the heating temperature would be higher than the other two surface temperature. So that is why heat goes like that. Okay. So that is, this one becomes K1 L1 and this one becomes K2 L2. So R1 and R2. So how do we write this R1, R2? Just a recap small. R1 equals R2 is equal to L over K into A. Substitute the K1 or K2 here. For this, substitute the L1 or the L2. Interesting, guys. Now let's go through something called guarded heating or thin film heaters 2 times here. Let's have first surface T1, second surface at a temperature Ts, third surface at a temperature Tp, and finally surface at temperature T4. Here the heat enters at Q dot S flux and Q dot P flux. These are respectively the heaters. Then you have the surface K1, L1, not a surface, sorry, composite wall. Here you have K2, L2. Here you have K3, L3. Now this is the concept of guarded heating. What happens in this circuit is you draw this, you draw another circuit, and you draw another one. Then you have T1, TS, TP, and T4, dude, nice. Here you have heat flux entering at Q dot S, and then you have heat flux entering at Q dot T. So that's it, guys, for today. So next video, what? We're gonna look at a solved problem. I'm gonna solve a problem with you guys. Let's have a good time. See you next video. Bye.